Here we go. I'm going to start recording. So we're going to graph quadratics today. This is when it gets fun. So before we actually graph them, I'm going to go over a few things. So today we're really going to talk about standard form. And you've graphed some quadratics. You've already done a couple. You took the parent graph x squared and you translated it. You might have reflected it or shrunk or stretched it, right? We did all that with that parent graph. This is a little bit different form for us, so we're going to use a little bit different method to graph, okay? So before I actually start, let me just review you on some key parts of quadratics. When you graph a quadratic, what does it look like? A parabola, okay? It could go up or it could go down, right? It can be skinny, it can be wide. That's where we start stretching and shrinking, horizontal stretch, vertical shrink, those kind of things, right? Compressions. All right, tell me what else you know about parabolas.
The x is squared.
I've got an x squared term. That's how I tell that it's a quadratic. What else do you know? What about the parabola itself?
It's not a function.
It is a function.
Right.
It's a function.
Sideways.
Okay, if it's sideways, it's not. What else do you know?
It never hits 0, right?
Domain is negative infinity to infinity, always, yes. What'd you say about 0?
I said it like never hits negative.
It can, it can.
You never like touch the
If it's real life, it stays in that first quadrant.
As approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches infinity.
If it's going up. Right, correct. In behavior. Good job. What else do you know? Tell me something geometrically about the parabola. It's symmetric. Does everybody agree it's symmetric? Everything that is symmetric has a what?
Line of reflection.
A line of symmetry or a line of reflection. That is absolutely correct. A parabola is no different, and it has one that goes right through the middle. So we are symmetric. This line of symmetry we are going to call the axis of symmetry. Axis of symmetry. Now, it goes through a very, very, very special point on my parabola. Does anyone know what this point is called that it goes through? Good job. This is called the vertex. The vertex is the point that the axis of symmetry, the vertical axis of symmetry goes through. Is it hot here, y'all? And it completely divides that parabola in half, okay? Let's see. It's also the point that if it's going up, that is a minimum value, right? Remember we talked about maxes and mins? Would that be an absolute max or an absolute min or a relative min?
Absolute.
Absolute. On these, they're always absolute. This would be an absolute minimum. What would this one be? Good job. Do we all see why? We did that graphical analysis, so hopefully you retained that you can apply this back to quadratics. All right. Everybody okay on what it looks like? Just remember too, because whenever we start graphing, this will come into play. If you have this point, it's easy to find the symmetrical point on the other side, right? And if I'm on a graph and it's just going straight across, I can literally count. If it's 3 spaces to get here, then 3 more over this way would give you the reflected point. So just remember how we reflect those points. Those are easy reflections over a line. All right. Haven't done too much, right? Let me show you what the equation itself is going to look like. Because we can do a little bit further analysis given the equation. Remember before we just had the parent graph of x squared. But remember, just like with a line, there's different forms. We have point slope, slope intercept, and standard form of a line. This is standard form of a quadratic. So A, B, and C are coefficients, okay? And it tells us a lot about the graph. A probably gives us the most information, okay? If A is greater than 0, so I'm talking about if A is what kind of number? Positive. Then my parabola is going to open up. If A is less than 0, what do you think is going to happen? It's going to go down. My A also has to do with my compressions and my stretches, okay? So if A, and I'm going to say the absolute value of A, because again, the positive and negative has to do with up or down, okay? And the A here, if you remember, whenever you negate, remember it reflects over, if you negate X, it reflects over Y, so that's kind of what it's doing here. Okay? Your A is also your shrink or stretch factor. If the absolute value of A is greater than 1, it is a horizontal compression, which means it shrinks it in, right? It gets to be a really skinny graph. It maybe goes from this to this. So the bigger A gets, the narrower the graph gets. So then as the absolute value of A gets smaller, it's a horizontal stretch, which means it's getting wider and wider and wider, right? Fractions, decimals, a half, a third, a fourth. So maybe this is the greater than 1, and then this would be less than 1, okay? 1 is your parent graph. That's your average width, okay? So it's the same width as the parent graph there. One more little thing to point out. Tell me what you know about intercepts. What happens at every x-intercept?
A 0.
What's 0?
Y.
Y. At every x-intercept, y is 0. And at every y-intercept, x is 0. If you plug 0 in for every x in this equation, what are you left with? That's your y-intercept. All right, y'all ready to graph? Okay, so here we go. We're going to do it anyway. Say again? No, parabolas don't have a slope. X is just your x value. So my equation may look something like this. Let me get one that's going to work out nicely. So x is just a part of your equation, okay? Your input values. Let's talk about what we know. Yeah.
This is off topic, but how is a parabola a function if x can't have an exponent greater than 1?
That's when you're talking about linear.
Okay.
Yeah.
That just like popped into my brain.
Yeah.
I was like,
It can't be a linear function, but it can still be a function.
okay.
All right, so looking at this, tell me what is A? 1. I don't see it, so it's 1, right? What is B? How about C? Looking at this, you know some things already. What do you already know about what this graph is going to look like? The y-intercept is -3. What else do you know? It's going up. It's a positive parabola. It's going up. How about the width of the parabola? Like, is it going to be skinny, wide, or it's the parent graph, right? So it's just an average width, right? The same width we're used to dealing with. Yeah.
Okay, so you said if it's greater than 0, it's
Correct. Then you wouldn't have an x squared term and it wouldn't be a quadratic.
Okay, what if it's greater than, like, the absolute value of a is greater than equal to 1?
If it equals 1, it's the average parent graph. It's the same width as the parent graph, so it's what we would consider like an average width. All right, so we've been able to tell a lot of things about this so far, right? Let's jump into graphing. So this is graphing in standard form. I should have put that at the top, I'm sorry. I'm going to give you some steps here to follow through because the graphing in standard form is always going to be the same steps as you go through. All right, we'll talk about some other forms probably next week. We're probably going to stick to standard for a while until we figure out how to manipulate this equation into some different forms, and then we'll talk about graphing in those different forms. All right, so what I want to do first is the first thing I want to do is find the axis of symmetry and the vertex, because those kind of go hand in hand. Why do those go hand in hand? That's exactly right. The axis of symmetry actually goes through the vertex. By finding the axis of symmetry, I've essentially found half of the vertex. Okay? So let's look at this. I'm going to give you a little formula. Okay? Oh, I know. Oh. To find the axis of symmetry. Now, if it's a vertical line, then it's in the form of what? How do you write the equation of a vertical line? If I had, yes, x equals, if I had a vertical line at 2, the equation of that line would be x equals 2, right? So it's in the form x equals. So to find the equation of the axis of symmetry, I'm going to do x equals, I'm writing negative b, but I like to say opposite b so it doesn't confuse you, okay? Because if it starts out negative, it's going to change it to positive. So opposite b over 2a. Well, I've already defined a, b, and c. I've got it written over to the side, right? So I should be able to just plug and chug on this. Negative 4 divided by 2 times 1, which is 2. And I'm going really slow here since this is the first time you've seen it. So this would be negative 2. Does that make sense? I just plugged in that little formula. Okay, so this is giving me the axis of symmetry, which is the absolute middle of the parabola. So I'm going to go ahead and graph that just to have it here. Let's see. So at negative 2, I have an axis of symmetry. It's not actually a part of the graph, so I'm going to dash it. So I know that's not part of the graph. That's just the middle, okay? It's going to keep me in line here. Now, tell me this, and here's where you got to think about it. Do you agree that somewhere on this line up and down lies my vertex?
Yes.
How could I tell where? Where what? This is x equals negative 2. You plug it in. Absolutely. Because any point on that line has got an x value of negative 2. Do you agree?
Yes.
I just need the y value. Well, my equation says y equals, it tells me what y equals at certain points, right? So plug it in and find out. Well, y is going to equal, watch your signs here, negative 2 squared plus 4 times negative 2 minus 3. What's negative 2 squared? Minus 8 minus 3? Negative 7. So the point, you're exactly right. The point, the vertex, which is a super, super important point, because remember, it's also the absolute max or the absolute min, depending on which way my parabola is going. Somebody's alarm's going off. 1, 2, 3, 4, 5, 6, 7. It's going to be right there on that dotted axis of symmetry. That is my vertex. I always put a little V here as I'm starting to graph these so I remember where my vertex is.
And by the way, that alarm is not, it's on my timer.
I mean, it's okay.
Yeah, when it bangs around your bag, I don't know how to work the timer. And it goes off every single day at 10:26. I don't know how to fix it. So my bag just happens to be with me.
So your bag is going off.
So I know what time it is, it's 10:26.
All right.
Plug in the axis of symmetry numbers
Plug in the X, yep,
for X.
for Y, yep, and find Y. All right, other questions about the vertex? Yeah. You absolutely, good job, Katie. You absolutely could. That's what I would suggest on this. Well, yeah.
Oh, and then you could just do the symmetry thing that you were
Y'all are so smart. I've never had a class just jump to everything before I go. Good job. Okay, so on this one, when you have the y-intercept, now, the y-intercept may not always be this easy, right? What if this said minus 20? Okay, or minus 120? I mean, you don't want to count, you know what I'm saying? So we'll talk about what we do when we get that far. So I call this, I need an easy point. Okay, if the y-intercept is easy, use it. Now, what if your vertex sits on the y-intercept? You can't use that for a second point because your vertex is already there. So there will be times when you'll have to find another point outside of the y-intercept or the vertex, right? And in that case, I just go right beside the vertex. If my vertex here is -2, I'll choose -1 or -3, and I'll stay right beside it, okay? But if you can, use the y-intercept because there is no math at all involved with that. And it's super duper easy, okay? And I'll show you how we could use another point also in case you can't use that. But in this case, Katie and Callie are absolutely right. I've got this -3. She said, well, I was going to get to you whenever I said reflect it. I'm sorry.
You just forgot my name.
I didn't forget your name, yeah. Callie would mouth too, and she's like, I was fixing to say that too, so I didn't want to leave her out.
So when you use the point beside it, you just plug that in.
Yes, and you would plug it in. It's more work, which is why we don't want to use it if we don't have to, but yes, you would just plug. I'm going to show you. I'll show you. All right, so I'm going to use -3. Because that's the y-intercept, and it's super easy to plot it right there. Okay? Now, if you couldn't use it, okay, if you can't, then pick an x that's close to your vertex. So I'm going to say, if not, pick an x close and plug it in. Well, what's close to -2?
-1.
-1. So maybe I let x equal -1 and I plug that in. Again, you don't have to do both of these if you only need one easy point, okay? So when I plug this in, I get -1 squared plus 4 times -1 minus 3. And what does that give you? 1 minus 4 minus 3? Yeah, -6. One, -6. Okay. This is going to be a little... No, because that's not -6, Stacy. I was like, what is wrong with my parabola? Okay. So now, just like Mary said, we're going to reflect over. This is my favorite step. I call it reflect and connect. Okay, so step 3. Oh no, I'm out of room.
You got to negate over the line.
You're just going to reflect over, well, you're going to reflect over the axis of symmetry. Okay, so if you're, wherever your axis of symmetry is, reflect that point, and then you connect into a nice parabola. So if I use the y-intercept here, Again, you don't have to have both of these. You just need one easy point. Reflect over that axis.
Okay, so that's how it's reflect, right?
Yep.
So, like, okay.
Just count. This is an easy
Yeah,
reflection.
that's what
Okay.
I did that, I think, on separate classes, and one time I was like, I don't know if this is how it's
Yeah,
supposed to
that's how you
reflect,
spell-
so
yeah.
that's how I am.
And then here, I mean, you could algebraically go in and subtract and do all that, but these are easy reflections, okay? I went ahead and reflected both of them just to show you. Again, you need a total of 3 points. One of them must be your vertex, and then you need one on either side of the axis, okay? If you don't want to reflect and you want to choose another point on the other side and plug in, then you just like to do that kind of work, that's fine. Now remember what parabolas look like. These are not absolute value graphs. They don't come down to a sharp point, okay? They curve and they're smooth into it. And it's a little easier to see how these ends are increasingly going out whenever you have more than just 3 points. Remember, nothing ever leaves us. What is the domain of this function? Yes. Every quadratic here, the domain is negative infinity to infinity. Some of you lost points because you're not doing interval notation. It's not all real numbers, it's negative infinity to infinity. Yeah. Left to right. Our range is what's going to be restricted. Speaking of range, -7 with a bracket to infinity. Everybody okay on that? Does this one have a maximum or a minimum?
Minimum.
Minimum.
Absolute minimum at -7.
At -7. So this is important, okay? Because, Noah, you're absolutely right. And the way in which you say it is very important, okay? This function has a minimum value of -7 at x equals -2. The value of the function is -7 at x equals -2.
Could you not just do absolute
Because you gotta say where.
Yes, but if you see something like determine when the function has a minimum value of 8, well, you can, from that you can go, oh, well, if it's got a minimum value of 8, that means the y value is 8. And I can also infer that that is the vertex. You see what I'm saying? So you have to be able to interpret the wording there and know what they're talking about. All right, one more. Una más, una más. Ooh, I like it.
More for more. For real. Don't make me sad.
Then I want to do one where we're not graphing, we're just doing a little bit of analysis on it. Let's say, what does that mean? Y. And what does it tell me? If I say f of x, it's a function. What does it mean to be a function?
You pass the vertical line.
Passes the vertical line test. Good job, y'all. Okay. F of x equals, I'm going to even throw you off a little bit. No, don't write that yet. I don't want that one. I'm sorry, I want one that goes down. Let's do, why is it so hot in here?
It's cold.
I really don't know. I hope this is going to come out good. Well, this one I did. I wanted to have, sometimes I just pray. But sometimes, like, I've done quadratics so many times, I can usually come up with ones that are nice. And yeah. That has what? No, everything will be in standard form Friday. Yes. Tell me what you know. A is -2. Y-intercept is 1. B is -4. What else do you know?
It will be
Go down.
It's going down.
Which means it's on horizontal.
Because the first number, the A, is negative. It tells me it's going to go down. Skinny, wide, or average?
Bigger?
It's gonna stretch.
Shrink, it's going to shrink. It's going to compress.
Yeah. Oh, it's greater than 1.
It's what, Lizzie, say again? It's absolute value. That's exactly right. You're already on step number 2, is that what you said? What did you get for your axis of symmetry? Of symmetry. So we're doing opposite B over 2A. Be very careful. Be. Noah, come on.
No, you're the only one who laughs at her.
I know, and he's leaving me hanging here. All right. Be very careful. Let's try again. Okay. Be very careful when you do opposite B. Well, I got okay.
You're laughing at someone laughing about it.
Yeah. Well, because I can relate.
Yeah, because you do crack a lot of jokes.
I crack a lot of jokes that nobody finds funny. They just fall flat.
They're like clever, but they're not like, oh my gosh, hilarious.
Yeah.
I know, I get it.
I like clever jokes.
Yeah, you like that, I'll be. Take a break.
Opposite B would be 4 over 2 times negative 2.
-1.
-1. -1. Is that what we had before? We had -2 before that.
Yeah.
All right, -1.
Oh my gosh, Noah.
We have our axis of symmetry at -1. Now I need to know where on this axis of symmetry do I go for my vertex. Plug it in. Good job, Adea. Yay. All right, so I have -2 times -1 squared minus 4 times -1 plus 1. Be very careful with your order of operations because exponents come before multiplication, so I need to square, right. I need to square that -1 before I multiply it to -2. So this would still be -2, this would be plus 4, and this would be plus 1. 3. And if I've done everything correctly, hopefully I will go down. Down, baby, down. Okay,
Is that a 60?
yes. Square it first and then. That's a 3. So this is my vertex. It is at the point -1, 3. Okay. Is that going to be a maximum or a minimum, by the way? Hopefully a max if I've done it correctly because it's going down, right? Absolute or relative?
Absolutely.
Always absolute on quadratics because it's not going. Good job, y'all. All right, my easy point. I'm going to use the y-intercept. I'm going to use 1. So 0, 1 is a great easy point. And then what do I do? Reflect it and connect it. What is your domain? What is the range? Good job. Listen to this question very carefully. What is the maximum value of the function?
3 at -1.
What is one number? What is the maximum value of the function? 3. Where does the maximum value occur? At x equals -1. Good job, y'all. I'm so proud. Say again. Where does the maximum value of the function occur? And it's at the vertex. It's at the y of the vertex. So it occurs at 3. Or the maximum value is 3 at x equals -1. Maximum value. All right, look at this equation, and this is the last one. Think about this. We're not actually going to graph it. We're going to think about some things. Think about it. Think about it. Think about it. Whoa, what is wrong?
It's out of order.
It's out of order. If I really want to do a good analysis on it and be a good little mathematician, I will always make sure that my equations are in standard form, which means they go from highest exponent down to lowest. What's the y-intercept?
2.
Yay! Is it up or down?
Up.
Up. Skinny, wide, or average? Average. What is the equation for the axis of symmetry? Good job. Opposite B over 2A, so 4 over 2 times 1. Does this function, without graphing it, have a maximum or a minimum?
No.
Which one?
Minimum.
Minimum. If it opens up, then it bottoms out at a point, right? What is the minimum value of the function?
Yeah, he always
Whatever the versus -2.
The minimum value of the function is -2. It occurs at x equals 2. How did I get that? Huh? The minimum value happens at the minimum. Okay, so it's the vertex there. The vertex is if you plug in 2, opposite B. So it'd be positive 4 over 2A. Four minus 8 plus 2 would give me the -2, and that's where I get it from. All right. That'd be the last thing we do. Because we're going to talk about every other way to solve besides that first.
What did you say?
What, -2 what? This is just how I found -2. I plugged in 2 to the equation. Talk through this problem. A souvenir shop sells about 200 coffee mugs each month for $6 each. The owner estimates for each 50-cent increase in price, he will sell 10 fewer mugs per month. How much should he charge to maximize profit? All right, so I know I'm going to have a quadratic, right? And I know I'm going to be talking about a maximum, so I'm trying to find a vertex of this quadratic. I need the equation of the quadratic.
Would it be x2?
It's definitely going to go down, and I know that because I want to maximize, so I'm going to have a maximum, right? All right, so let's look at the information we have. 200 coffee mugs each month, $6 each, right? If I subtract the price by 50 cents, then I sell 10 fewer mugs, right?
Wait, subtract the price or increase?
Subtract.
I mean, increase the price 50 cents, then I subtract 10 fewer, right? So let's let X, be the number of times, because I'm increasing by 50 cents each time. Let's say X is the number of times I increase. Bless you. Okay. So if X is 3, how much am I charging for a coffee mug? More than what I started with, right? If I have 3 increases, I'm charging $7.50 for a mug, correct? Okay, if I increase 3 times, that's 50 cent, 50 cent, 50 cent, then I'm charging, I started at 6.
And you're only getting 170 sales.
But it's, right, so plus 50 cent times the number of increases. That's my price of cups, right? Are we all in agreement there?
Yes.
But what I have to do, I have to take into account what's happening with my fewer amount, right? Are y'all with me?
We should.
I feel like we're not going to have time to get through this. Is it 11:05 or 11:15?
Get out.
What I have to do, you got to think about how I find out how much money I'm making, right? I take the number of people, right, times, or the number of mugs times how many I sell, okay? We don't know what. I'm going to get to that. Okay? So to find out what something costs, you find out how many you sell and multiply it by what you charged, right? Are we all with that? So let me just start this over. Shh, shh, shh. Come on, pen, please do this. This is hard enough on its own. There we go. All right, so to find cost, or to find how much I make, this thing's getting on my nerves. You getting on my nerves? As soon as it quits, I'll write it for you. There you go. Number of mugs times what I'm charging for the mugs, right? So we got two separate things here. We got two separate things we got to look at. How do I find the number of mugs? And here's where you have to think. I'm selling how many of them?
200.
200. But every time what happens?
You're going down when you.
Every time I increase by 50 cents, I'm going down 10 mugs, right?
Correct.
Minus 10 times X. Because if I let X be the number of times I go down, then that's telling me how many mugs I sell. Does that make sense?
Plus 0.5. X is number of times you
Okay, the number, so X is the number of times that I'm increasing my price.
Okay.
If I increase twice, I've increased $1, okay? If I increase 5 times, I've increased $2.50, right?
Oh,
Okay?
Yeah.
All right.
Losing 50 customers.
But every time I do that just one time, I lose 10 customers, right? So maybe I sell 600, but if I increase 3 times, I've lost 30 of those. Yeah, I'm making $1.50 more a mug, but I've lost 30 customers. So the question is, when is this maxing out? What's my optimum amount to charge for the mug to make the most amount of money? How many increases should I do? All right, so this is the number of mugs that I sell, right? Is everyone in agreement on where that came from?
Yes.
The number of mugs I sell is 600 minus 10 every time I do an increase. But I need to multiply that by how much I charge per mug, right? So I'm charging $6 plus
0.5x.
50 cents every time I do an increase. Are y'all with me on that?
Yes. And you
Okay.
can use the same x.
Now your equation is set up. Okay, so how is this a parabola? We got to FOIL it. Oh my gosh, y'all. This is, once you get it set up, it's a cinch.
But you make the smile face.
It's like first outer inner lash.
All right, look, I just want to get through this one with you because you have several like this on your homework. I want you to be able to set it up. I think if you can look at it and understand that number of mugs times price per mug gives me the total money I've made, then it's easier to set up that way. You just have to think through, okay? All right, 200 times 6 is
1200.
1,200. Woo! 200 times 1/2 x would give me 100x. 200 times 0.5x.
Or negative 6.
Minus 60x. X squared. There's my squared term. There's where I know it's a quadratic, right?
And then you have to put it back into the.
If I put in standard form, now, I can look at this and I can tell a lot of things about this without even graphing it, right? It's going down. If I want to maximize profit, I needed it to go down, so that's correct. Go ahead, Connor. We're not going to even do any of that because we're not going to graph. What we're going to do, because it asked me for maximum profit, right? I want to find the maximum. The maximum happens where? At the vertex, right? So to find the vertex, I first need the axis of symmetry, and then I need the y that goes with it. Okay? So opposite B over 2A. I think this is pretty cool because y'all are always asking me, when would we ever use this one? Look, you open a campus store and want to sell mugs, there you go.
X is much easier way to solve
Not gonna
that.
happen.
X equals 4. Now what is that telling me?
So at $4,
Not $4. What does X represent?
X is the number of times you
4
increase.
times of increase.
If I increase 4 times, $2, right? So what is my price of mugs? What's my optimum price of mugs? $8 gives me the most profit. How much? Okay, so $8 for a mug is what I need to charge. How much money am I going to make when I charge $8 a mug? You're going to plug it in.
Because it's 4 is the vertex, so that means times the so it's like $4 $9 $2.
Because 4 increases, if each increase is 50 cents, 4 increases would be $2, and they started at $6. All right, so look, several of you are asking about the price. If I started at $6 each time I increase, it's increasing by 50 cents. So if I increase 4 times, that's $2, right? $2 increased from where I started with. So it gives me an $8 mug. If I start at 6 and I do 4 50-cent increases, I'm at $8 per mug. Has anyone found the total amount of money made? Yes, Lizzie. $1,280 is what you'll make off of your mugs if you
But
plug
where
that
do
in.
you
Minus the cost, of course.
So where do you subtract, did we already do the subtraction of the customers? Because we have to subtract.
So I took that into account in my initial equation. Remember we said we're going to do the number of mugs
Okay.
times the price, right? Times what we charge.
Okay.
So the number of customers, I have 200 unless I increase. Every time I increase, I got to take 10 times that away.
So that's what that means.
Correct.